Continuing from the 51st question, electrification by rubbing two bodies together is due to transference of charges, that is electrons, transfer of electrons. So B is the right answer. So let's go to next question. 52nd, the point charge 1 coulomb exerts a force mutually 1 meter apart. So then force value itself is 9 into 10 to the power 9 Newton. So that will be the force value, which is B. Okay, let's go to 53rd question. The two spheres having the surface charge density in the ratio 2 is to 3, the radii in the ratio 3 is to 2. The relation between surface charge density and the charge, surface charge q by if the sphere 4 pi r square. So then from which you can write what is q. Q is okay, the ratio of the charges. Okay, so you know sigma is equal to q by 4 pi r square, and therefore q is equal to sigma into 4 pi. You can imagine sigma is charge q is equal to sigma into 4 pi r square. The charge q1 is sigma into 4 pi r square, and the charge on q2 is the surface charge density into that 4 pi r square. And when you divide, the 4 pi and 4 pi get cancelled, you get a ratio of q1 by q2, which will be sigma surface charge density, which is 2 here, and a 3 square has to be multiplied by 3 into 2 square has to be multiplied. So you get an answer which is 3 is to 2, and A is the right answer. Let's go to 54th question. An electric charge is placed at one of the corners of the corners, you know it, then the flux coming out of one of the faces is q by 24 into epsilon naught. That's option number D. According to Gaussian's theorem, electric field of an infinitely long wire is inversely proportional to radius. You know it's k 2 lambda by r, so C is the right answer. 56th question, which of the following statement is correct, okay, or incorrect? I'll go for the incorrect one because I didn't take a picture properly. Okay, look at this. The quantization of charge was experimentally demonstrated by Newton. No, it was found by Millikan. Just know it. Okay, it's not Newton. Quantization was done by Millikan. So let's go to next question. Look at this diagram. As soon as you see A is so close to each other, the electric field line. So EA is greater than EB. So the electric field at, and I can say they're emanating from A, so it's positive at A. The terminating at B, so it's negative at B. So A is positive, B is negative, A is greater than B, or the magnitude of A is greater than magnitude of B, where A is positive and B is negative. So option number A is the right answer. The 58th question, it's a non-uniform electric field. The electric field is greater at the left end, so then the dipole will move towards the left. The dipole will experience a force towards the left because the electric field there is greater. So then actually speaking, it will also experience a torque. In addition to it, it will also move towards the left, but keep that in mind. So match the following. 59th question. Okay, yeah, okay, look at this. This first one shows that it's emanating from positive, so it's a unit positive charge, a single positive charge. So R, A is related to R, B is negative charge, single negative charge, which is S, and C is they emanate and little pressure to both of them, a pair of positive equal and opposite, equal and like charges, and it's emanating, so two positive charges, a pair of positive charges, which is Q is what is C related to, and what is D? D is like a positive and a negative, it's like a dipole. So the left is positive, the right is negative, equal on opposite charge, which is P. So this is the way it has to be, and A is R. So R S P Q. So option number C is the right answer. 60th question. The 60th question itself is incorrect. In case at least what is correct we'll answer. Infinite plane sheet. It will be sigma by 2 epsilon naught. So that will be A is Q. An infinite plane sheet of uniform thickness, that we don't know, the B. Okay, actually when I did the answer, it was talking about a non-infinite plane sheet. So can you see, I don't know, B is talking about electric field due to long wire. Electric field due to long wire is lambda by 2 pi epsilon naught r. These two we are clear about, we can mark those. And for option the B's answer is not clear because it says non-infinite on the answer sheet, and it's infinite plane sheet of uniform thickness. What does it even carry a charge? The question is not so clear. Okay, so then let's go to next question. Shit, what did I do? Which sum was I in? I was in 61st question. Assertion reasoning. When we produce a charge q1 on the body by rubbing it against another body, we get a charge q2 in the process. Okay, and a q1 plus q2 is equal to 0. You're literally rubbing it on another body. You're producing charge by friction. We produce charge q1 on the body by rubbing it against another body. We get a charge q2 in the process. Then q1 by q1 plus q2 is equal to 0. When we produce a charge q1 on the body by rubbing it on another body, we get a charge q2 in the process. Then q1 and q2 both are equal in magnitude but opposite in polarity. Hence q1 plus q2 is equal to 0. By rubbing? I'm not sure of this assertion reasoning. One second, hold on. When we rub one body over another, some charges gets transferred from one body to another due to while rubbing, and so then the charge lost by one is a charge gained by the other, and so the conservation of charge, net charge will be q1 plus q2 will be equal to 0. So assertion is true. The charge on isolated system remains constant. That is also true. So then and that's the reason why when they both are together, it becomes an isolated system and net charge is 0. So correct explanation. 62nd question. When a charge are shared between any two bodies, then no charge is really lost, but some loss of energy does occur. Yeah, we saw even in capacitors, when we connected to capacitor sharing, the charge gets shared but some loss of energy did occur. So assertion is true. And reason, some energy disappears in the form of heat and sparking X, that is also true. So both of them are true. And 62nd, but the reason is not the correct explanation. Okay, some energy do get lost in the form of heat or sparking, but that's not the explanation why some energy loss occurs. So just get to know it. It's kind of complicated. The 62nd, to say that the reason is not the correct explanation is quite a complicated one. 63rd, assertion. At macroscopic level, the quantization can be ignored. Yes, obviously. Macro means bigger. Okay, quantization refers to very small value, correct? So then therefore it can be ignored. One microcoulomb is 10 to the power minus 6 divided by 1.6 into given charge by Q by E, contribute 10 to the power 13, but here it says 10 to the power 15. So therefore the reason is false. So let's go to next question. 64th. The mass of the body does not increase when negative charge. It increases. A slight increase in charge is there. That's what we learnt. Okay, 64th question. Once again, what is this? A mass of the body does not. Oh, then there increases. So then therefore it's false. And when negatively charged, it increases by 9.1 10 to the power minus 31 kg. Charge is not mainly due to transfer of electron. It's mainly due to transfer of electrons. So that is again false. Okay, assertion. The gravitational force is dominating force. No. Electrostatic force is greater than gravitational force. So false. Reason, the Coulomb's force is a weaker force than gravitational force. The reason is also false. The Coulomb's force is a stronger force. 66th question. At the center of the line joining the two equal charges, electric field can be 0. No. Nowhere between positive and negative the electric field is 0. So assertion is false. At the center of the line joining two equal and similar charges, plus q, electric field can become 0. Yeah, so the reason is also false. Assertion. Point charge is brought in an electric field. The electric field at the nearby point may increase or decrease. True. Reason, the electric field is dependent on the nature of the charge. 67th. Yes, the electric field Depend on the nature of the charge, yes. Okay, so then the electric field at the nearby point will be the resultant of the electric field produced by this point charge and existing electric field. And so then the net electric field gets affected, may increase or decrease depending on whether it's positive or negative. And so then, and that's a right explanation, true. 68th, acceleration of the charged particle in a non-uniform electric field does not depend on the velocity of the charged particle. Okay, since acceleration F is equal to m into A is equal to F by m, which is also equal to charge by mass ratio Q by m, because for a given electric field E will be a constant, so Q by m. So E changes, as E changes, A also changes, but it does not depend on the velocity of the charged particle. What is it? Acceleration of the charged particle in a non-uniform electric field does not depend on the velocity of the charged particle. It only depends on charge by mass ratio. Okay. Therefore, both A and R are true, but R is not the correct expression. What is R? Charge is invariant quantity. What is that? Charge is invariant quantity. It's not going to vary, it's going to be a constant. Yeah, I don't understand the 68th assertion reasoning, guys. I don't really understand that. Okay, so 67th, the electric lines of force cross each other. No way, false. Electric field at that point does not superimpose to give one resultant electric field. At any point is equal to the vector sum of the electric field at that point due to various charges that is existing. So then electric field at the point does not superimpose. Yes, it does superimpose. So can I say that 69th reason is false? Yes, R is false. A is also false. So let's go to 70th question. Where am I pressing? Somewhere it goes to 70th question. Away from a charge, field lines gets weaker and density of the field line is less, resulting in well separated lines, which is true. Only finite number of lines can be drawn from a charge. No, that's false. So then 71st question, on going away from a small electric dipole, electric field decreases. Yeah, on going away from a small electric dipole, the electric field decreases. The electric field is inversely proportional to the square of the distance. For a dipole, we saw the potential is inversely proportional to r square. What about electric field along an axial line? It's inversely proportional to not square, it's only inversely proportional to r. So r, 71st r is false. 72nd, in a non-uniform electric field, dipole will have translatory as well as rotational motion, which is true. And the reason in non-uniform electric field, dipole experience torque only. No. What is this? Okay, so then 73rd question. If the dipole is enclosed by a Gaussian surface, then the flux coming out will be 0, true. The charge enclosed by the surface is 0, that's also true, and that's the right explanation too. 74th question. In a region where the uniform electric field exists, the net charge within volume of any size is 0. In a region where uniform electric field exists, the net charge within the volume of any size. I didn't understand this question. Within the volume of any size. The region where the uniform electric field exists, the net charge within the volume of any size will be 0. Okay. In a closed body, let me read the solution, is placed in an electric field. If a closed body is placed in an electric field, either uniform or non-uniform, the total flux linked with it will be 0. because flux will be the charge enclosed, whereas this uniform electric field indicates that the charge is not inside it. Okay, the electric field would have emanated from a charge, but where the electric field is existing, there will be no charge, and hence we can say that the net charge within the volume of any size will be definitely zero. Okay, that's nice. And the reason the electric flux within any closed surface in a region of uniform electric field is zero. That's again true, and that's a correct explanation. 75th question. Upon displacement of charges within the closed surface, E at any point on the surface does not change. Due to displacement of charge within the closed surface, E at any point may change, but the net flux crossing the surface will not change. The net flux crossing, okay, the flux crossing through the closed surface is independent of the location of the charge. The charge may be located anywhere inside. The flux will not change, but the electric field at that surface will definitely change depending on its position. Okay, so then what can we say? Upon displacement of the charge within the closed surface, E at any point on the surface does change. So E at any point on the surface, isn't it true? Because electric field is 1 by 4 pi epsilon q by r and depends on the position r from it. So if you're going to change it around, definitely E will change. I don't know, I don't agree with the answer that he has put. And the reason, the flux crossing the closed surface is dependent on the location. The flux will never depend on the location. It only depends on the enclosed charge. So it seems like, according to me, the reason is false. And the assertion E at any point does change, yes. So true and false. Assertion is true and reason is false, but here seem to be saying something else. Just we'll discuss this in the class, but just see what you've written. If you've written what I said, it's fine. And the assertion, E in outside vicinity of conductor depends only on the local surface charge density and is independent of the other charge present anywhere in the conductor. Vicinity of the conductor, E is outside vicinity of a conductor depends on the charges present on the space, and it's expressed as E is equal to sigma by epsilon naught. Therefore A is false. And is independent of the charge present anywhere on the conductor. If it's going to be dependent on charge density, and again it's very confusing. The assertion reasonings are always very confusing. One second, hold on. So don't give yourself the mark for assertion reasoning. Assertion reasoning is only for you to think, okay? So then whatever is the answer, we'll brainstorm in the class. Skip the assertion reasoning question in terms of giving yourself marks. If you've gone wrong, just don't consider. Look at this, E outside vicinity of a conductor is 2 sigma by. What sort of conductor is it? It all depends on what sort of conductor it is spherical, or I don't understand this point at all. So for now ignore the 76th question also. So let's go to next one. Is 77th. When a glass rod is rubbed with silk, it becomes positively charged because the silk would have gained an electron. Electron gets transferred to silk. So option number B is right answer. 78. Which of the following method can be used to charge a metal sphere positively without touching it? 78th. Without touching it means induction. So if a negatively charged rod is placed near the sphere, you have an option like that. Yeah, option number. Bring the negatively charged rod near it and touch it to the ground for some time. Yeah, C, option number C. So 79th question. We have two bodies with charge Q1 and Q2. On them Q1 plus Q2 is equal to 0. So that is equal and opposite charge Q1 and Q2. So that's the option, equal and opposite. So option number B. If an object is positively charged, theoretically the mass of the object decreases by 9.1 10 to the power minus 31. So let's go to 81st question. And so decreases by small factor. B is the option for it. 81st question. The value of charge on the body which carries 30 excess electrons. So N is given. Q is what you are asking. Q is equal to N into E. So N into E. So you have N and you know E. You can multiply. And 1.6 10 to the power minus 19. So minus 4.8 into 10 to the power minus 18 coulomb. Excess electrons, so it has to be negative, and there's no negative symbol. I think there should have been a negative in option number A, which is missing. So obviously we have to think about it. So next is this 82nd question. E in the outer region, outer region of the first place, which is they're talking about region 1, region 2, region 3. So then you know it's between a positive and nowhere between positive and negative the electric field will be 0. It will be left to the left and the right the electric field can be 0, and so to the left of it in region 1 it can be 0, and electric field outer of the second place again it can be 0, and in between the plate it will be sigma by epsilon naught, and whatever is the value of that, which is the 84th. 1.92 10 to the power minus 10, which is C, option number C. So 85th question, the ratio of E from the right side of B at a distance 2 cm and 4 cm respectively. I told you that the electric field will be independent of the position in series of plane sheets, so 1:1. In order to estimate the electric field due to thin finite plane metal plate, the Gaussian surface considered is thin metal plate. It's a horizontal cylinder, right? And so next question is so it's cylindrical, option number B. So let's go to next question, sum number 87. Electric field lines always move from positive to negative, or you can say higher potential to a 87, most higher potential to low potential. So answer is option number A. 87th. 88. So 88th question. Choose the correct statement. The electric field in a region is strong when the electric field line in that region are closely spaced. So that's the right answer. That's the right statement. So closely spaced regions of electric field represent strong electric field. So option number B. The spacing between the two electric field line indicates its strength only. 89th, it only indicates the strength, intensity, or we can say intensity. So option number C. So 90th question, the electric field lines of negatively charged particles. Electric field lines of negatively charged particle are directed inward, radial and inward. So then that's option number B. 91st question. The electric field lines start from positive and end at negative. So you know that the process of alignment of the dipole moment in accordance with the electric field. Okay, so you know that 1 is definitely positive and 2 is definitely negative. Q1 is positive and Q2 is negative, and Q3 is again terminating. Q3 is also negative. So positive, negative and negative. Option number C should be the right answer. So let's go to next 92nd question. 92nd question. The dipoles of an electric field undergo always undergo polarization. So D. 93rd. Calculate the distance between the two charges 4 coulomb forming a dipole, which means plus 4 and minus 4. The dipole moment is 6 unit. P has been given, distance they're asking. P is equal to Q into 2A. So you have to find 2A itself. That's the separation, which will be 1.5 units. So option number B. 94th question. The dipole moment of two equal separation by 2 centimeter. They're asking for dipole moment, which is q into 2a. So either of the charge is 2 coulomb into 2a itself is 2 2 2 4 centimeter into meters. So then 0.04 coulomb meter. That will be option number B. A dipole moment are used to calculate at 95th. Used to calculate polarization pattern based on the applied electric field. Just remember that a dipole moment to use is to find the polarization pattern. Okay, so that's what it is. 95th question. 96th, what is the dimension of dipole moment? Dimensional formula for dipole moment is I T and ILT. Option number A is right answer. So then next is Faraday's cage. Which of the following material can be used as a Faraday's cage? It has to be a conductor, so copper. So it's option number C. Example of a real world Faraday's cage is a car. It's just a car, okay. So then if you go and sit inside the car, lightning and all will not affect you. And so then, so the real life Faraday's cage can be here a car. What is the electrical force inside a Faraday's cage when stuck by the net force will be 0. So then that's the 99th question answer. 0 is option number C. And just this last page, an isolated point charge Q is placed in a Faraday's cage. Its surface will have an equal negative charge. If it's plus Q, there will be minus Q at the surface of the Faraday's cage. So C. 100th question. Yeah, can you see? This plus, this is how it is. Okay, there will be surface charge density due to the plus Q at the surface of the Faraday's cage. The interior to it will be a plus Q, and exterior of it is minus Q, and so it develops a negative charge, minus Q. Okay, I hope you understood that point. It's very, very important. So minus Q should be the answer, option number C. And a point charge of 2 coulomb is placed at the center of the Faraday's cage in the shape of a cube, 2 coulomb. So what the number of electric field lines passing through the cube normally, the entire cube is just flux by Q, it's just Q by epsilon naught. They're not asking through one phase, right? They're asking through the entire cube. It's just Q by epsilon naught. And 2 coulomb charge is impractical value. What is it? Something is mentioned in the solution. The 2 coulomb charge is impractical value. So if you take Q is equal to 2 microcoulomb, oh yeah, if you take 2 coulomb, it's a very, very large value. If it's microcoulomb, so then you get it like this, which is close to option number C. So what is he trying to say? Is he trying to say that it should have been a 2 microcoulomb and not a 2 coulomb? Because when it's a 2 coulomb, you're getting the flux to be 0.226 into 10 to the power 12. What is he trying to say? It's leaving the surface. So, which is close to 2 into 10 to the power 5. So none of these values is closer, so it has to be 2 microcoulomb. Some assumption like that. But I hope you understood. The second part is like filled with lots of assertion reasoning, which is very difficult. And don't evaluate yourself with that. Assertion reasoning is something that will get clear over a period of time. But just get to learn it. And rest of the questions, just check how you've answered. Some question there are mistakes. A few questions here and there has got mistakes in the paper itself. So evaluate yourself and let me know, and do your exams well.